Hello and welcome to Anatomy Physiology Lesson 2.04. We're going to wrap up epithelial tissues in this lesson. Go to my screen share. Mm. All right, we left off with transitional last time. So we're going to get into the stratified tissues today. And our first one is stratified squamous epithelium. So you can see this tissue slide that you have in your packet. Excuse me. Let's look at the nuclei. So we have the basement membrane down here. We have the apical surface up here. And then down here we have a connective tissue. And we have to look at what's going on with the nuclei to determine what type of tissue we have. A couple of the characteristics. At the top, the older cells tend to be flatter, and the cells actually divide down here. So we have cell production here. And as the cells produce, they get pushed up. Let me pause and let you record or write. You're going to want to pay attention to whether or not the nuclei are around all the way to the top of this tissue, or whether the nuclei stop about halfway up and the nuclei are these black dots, because we have two different kinds of stratified squamous. On the test, if you tell me stratified squamous, I'll take off a half a point, because you have to differentiate between keratinized stratified squamous and non-keratinized stratified squamous. Let's write the notes down and then we'll talk about it. All right, so we're going to talk about keratinized stratified squamous epithelium. Say that 10 times really fast first. This is not keratinized. This is non-keratinized. How do I know that? I have nuclei that go all the way up to the top of the tissue, up to the apical surface. If this was keratinized, and I'm actually going to stop sharing, I'm going to pause, and I'm going to get a slide that shows the difference between the two. So let's write all the notes down, and then we'll get some different slides. Okay, so here is the notes for non-keratinized. Non-keratinized are found in moist surfaces. It's living tissue inside of the mouth, lining of the anus, and vagina. And again, I'll give you a second to get those. All right, I'm going to stop sharing this screen. I'm going to pause the recording and I will be right back. Okay, so I went ahead and I Googled keratinized versus non-keratinized. So in your notes, it says that keratinized is the surface of the skin and it says dead. Well, what does that mean versus living? So on the left, and you're going to get plenty of practice. I know you don't have this in your notes. Don't worry about it because we're going to practice this quite a bit in class. At the top, the apical surface of this, you'll notice I've got nuclei. So I'm definitely stratified. I've got nuclei, nuclei, nuclei. But when I get to the top, it gets this weird look to it. These cells are dead. There's nothing left in them but protein. Here I have the same thing. I've got nuclei and I definitely have layers, so I'm stratified, but notice the nuclei carry all the way up to the top. This cell at the top is alive versus these cells that are dead. Well, here's the deal. Cells, we are liquid creatures. 70% of our bodies are water, and if our cells aren't in contact with fluid, our cells will die. So this is going to be found inside the mouth, the back of the pharynx, lining of the vagina, the anus. It's moist. There's fluid. These cells can live. And they're produced down here and they get pushed up and up and up and up and up. And then at the top, they get scraped away. even though they're alive, it doesn't hurt because they're still mostly protein. But this is found outside on it's on the surface of our skin, and our skin's very dry. So as the new cells are produced, they go up and up and up and up, and they die. And as they die, the nuclei go away. So the protein that's left is called keratin, and that's why this is called a keratinized stratified squamous, and this is called a non-keratinized stratified squamous. So again, not in your notes, don't panic, but you do need to understand when you're looking at a tissue why it matters if the nuclei are at the top or not. All right, I'm going to stop sharing here and go back to my other screen. Share the screen. So we need to know where they're found and why they look the way that they look. And we'll get more practice identifying those later. All right, that's our stratified squamous. And again, to be specific, keratinized stratified squamous epithelium, non-keratinized stratified squamous epithelium. All right, stratified cuboidal are some of the easier ones. Let's get the notes first. So basically, we're looking at lining ducts. So we have the ducts of sweat glands and the ducts of the mammary glands. And so there's not really going to be many questions about this on the paper pencil portion, multiple choice, but you will see it on the tissue identification. So once you get the notes copied, we'll talk about how do you identify. All right, this is a mammary gland. So this is going to be my lumen here in the center, and the row of nuclei, anytime you see distinct rows of nuclei, that's a tip off you're looking at an epithelial tissue. So if you look, I have a row of nuclei here, and these are too short to be columnar. If I drew a box around that, that's definitely got to be cuboidal. And if you look underneath, here's a second row of cuboidal. Usually our stratified cuboidal are the only ones you're going to see are 2 rows thick. So you'll never see a stratified cuboidal that has more than 2 rows. So this is a great example of stratified cuboidal. You really can't see the cell membranes, but if you use the nuclei as your guide, you can kind of see that there would be a square around that. All right, that takes us to our last category. We're done with all of the tissues. So I want to talk about glands. We said back at the beginning that glands are always made up of epithelium as well, specialized to secrete and produce substances into ducts and bodily fluids. All right, I'll let you write down at the bottom. I have sweat gland, mammary gland, sebaceous gland. So I'll let you guys do your writing first, and then we'll talk about it. So what we have here, first of all, we're divided into endocrine and exocrine. And endocrine is endo, you guys know, means within, and exo means without or outside. So endocrine secretes into the blood. What you see happening here is this is my glandular tissue, and these are my substances produced by the gland, and it's going into the body, into specifically the blood. An exocrine gland secretes into either a lumen or into actually out of the body. It could be onto the body surface, but a lot of times it's into a lumen or a duct. So exocrine secreting into a duct, a lumen outside the body. Endocrine into the blood or to tissues. Exocrine, lumen, duct, or outside the body. Endocrine into tissues or the blood. Well, it turns out there's 3 kinds of exocrine glands. One kind is called a merocrine gland. One kind is called an apocrine gland, and one kind is called a holocrine gland. The example of merocrine would be a sweat gland. The example of an apocrine would be a mammary gland. The example of a holocrine would be a sebaceous gland. And they work a little bit differently. So a holocrine gland, it creates its substance, and then to release its substance, what you're seeing here is the entire gland is rupturing. I always think of holocrine being whole. The whole cell here is going to rupture and release its contents, and then the cell's gone. It can't produce anymore. So it's a one and done. On the other end, a merocrine gland stays steady. So this cell will hang around for a long time, and it creates its substance and it excretes its substance, and it'll create more and take it to the surface and excrete it and take it and excrete it. So if you think about it in terms of cytoplasm, the holocrine is releasing 100% of its cytoplasm. It's all gone. The merocrine doesn't release any of its cytoplasm. So when you secrete oil, remember sebaceous gland secretes oil? When you secrete oil onto the top of your skin, you have a cell that's rupturing to release its contents. When you sweat, you have your little sweat glands that sit in there and they release the sweat, but they keep chugging along. An apocrine is halfway between. An example of an apocrine gland is a mammary gland. So if a woman is lactating or producing milk, her glands take part of the cytoplasm and they take the substance, the milk, and they release it together. And so you actually lose part of the cell. So after a while, an apocrine would become used up and it wouldn't be good anymore, but it takes time because it releases it in pieces. So again, examples of each of those. And they talk about these are common terms in a freshman anatomy class. So I think it's good to discuss these. The last thing, and I wanted to highlight this again, was cancers and epithelial. We said that 80% of cancers are from epithelial tissue, and then the other 15% or other 20% are actually I think it's 85% are epithelial. The other 15% lie in the connective tissue, and there's like one or two muscle tissue cancers, but they're very rare. There's some connective tissues though, like if you have leukemia, it's in the blood, that's going to be connective tissue. But these guys are always reproducing quickly. And so that's why we see so many of the cancers in epithelial tissue. So if you have skin cancer, that's stratified squamous epithelium. If you have a lot of times cancers in organs, like a bladder cancer or kidney cancer, it's the epithelial lining that's gone haywire. It really isn't the tissues it's not the cells of that organ, it's the lining. So that's, we always try to talk about disorders and in tissues, not so much, but it is good to know about cancer and epithelial tissues. All right, that wraps up epithelial tissues. We're going to do 2 more sessions on muscle, and we'll just tack nerve onto the end of that. So that is all we've got for today. I'm going to stop sharing my screen. Thanks for watching and have a good day.